Hi, Miss Smith here, bringing you the third video and the last for showing you how to solve solve a rational function. So we've done our little acronym hide Z. That was my little thing or mnemonic device. You can create your own. Just do you. What can you remember to help me remember the different things I solve for when we're looking at a rational function? So H stands for horizontal asymptote, and we found that it was zero, or it's not zero, it doesn't exist. We had an oblique asymptote instead for our given example right here. Then we have our intervals, which we're about to view on our graph, and our discontinuities. We saw for those, we had vertical asymptotes, 2 of them. We found that by taking the denominator and factoring it and then solving for the zeros in the denominator. And then we have our zeros in the numerator, which we take our function from the numerator, the x cubed plus 1. And then we solve for our zeros, and we ended up with 1 real and 2 complex. So we're actually just going to graph the real. So now the last thing, we haven't been able to view our intervals. So we'll view our intervals in Desmos when we graph it. And then from there, we'll also be able to see our horizontal asymptote and check those, check our discontinuities, look at our end behavior, and see the zeros. All right, so now we're in Desmos and looking at our graph. So we have x cubed plus 1 divided by x squared plus 2x. So looking first at our horizontal asymptote, as I said, there wasn't one, but there is an oblique one, and that was at x minus 2. And you'll look at our graph, it indeed starts to behave linear, like the linear graph, x minus 2 right here. So that checks out. Then looking at our intervals, as x approaches from this side, it is increasing, and then, oh, it gets to a peak and then starts decreasing. And then, oh, it never reaches -2, and it jumps back up here on the other side of -2, and it is also decreasing all the way down. And then right here, after 0, it decreases, and then right here at this point, it increases from there on out. So looking at our intervals, we can see our behavior, or we can see the behavior on the intervals. Our discontinuities, we had vertical asymptotes. You had one at an x equals -2, and we had another one at x equals 0, and we can see that our graph does not cross either of those lines. And then our end behavior, since our exponent on the numerator is a odd number, we should have an odd graph. It should have odd behavior. No, or not odd even, or never mind. So it should have one side going up and the other side going down infinitely, and it does, so that checks out. And then our zeros. We had a 0 at x equals -1, and bada bing, bada boom. Right here, x equals -1, we have a 0. Everything checks out. That's a wrap.